All right, so this is going to be a series of tutorials on how to make bubble charts in D3, interactive bubble charts, specifically with D3 version 4. So it's a little bit different than version 3, so it might be useful if you did it with 3 and want to upgrade to 4. A bubble chart, if you don't know, it's a chart like this where everything is a bunch of bubbles, and the magic thing with it being interactive is we are going to be able to sort things like this and split them up into different segments based on certain categories of our data. So let's get started. This is what we have right now. We have a light gray SVG and then a couple circles huddling up in the top left-hand corner. So let's look at our code. Let's look at our data first. Our data is a series of musical artists and the number of millions of albums they have sold worldwide. This is kind of fake as well. And then there's a decade as to whether they are pre or post 2000. So we are going to resize these bubbles to be different sizes. We're going to kind of cluster them around the middle, and then we're going to split them into groups based on whether they are pre or post 2000. So our code itself as it stands is pretty simple. We have a height and we have a width of 500, so it's square. We pull up a div, this div right here, chart div, based on its ID. We add an SVG to it, we give it a height and width, we put a G inside, and we transform it to go actually nowhere. It stays exactly where it was. Generally, when you have a D3 visualization, you have all kinds of margins, and then there's all kinds of math to make the height and width, and then you transform in order to push your G in a little bit to give margins around the outside. You don't need to do that with force diagrams because force diagrams don't care about margins. Then we pull in sales.csv, which is the CSV we were looking at in Excel, and we draw circles. So for every single data point, we create a circle, we give it a radius of 10, a fill of light blue, and a class of artists. So that's where we're at right now. If we inspect, we have a whole lot of circles here, and they are all in the upper left-hand corner because this is 0, 0 according to SVG and according to D3. So normally what we would do is we would have a scale. We would have a scale for the x-axis, we would have a scale for a y-axis, and we would position each one of these circles independently. So let's just move them all to the same place, for example. So cx of 100 and cy of, let's say, 300. I'm going to save that, refresh, and now all of our bubbles are right here. It looks just like one bubble, but it is actually millions upon millions of bubbles right here, one for every one of our artists. So what we want to do in order to get to the New York Times visualization is we need to use something called D3 Force. D3 Force is a module that implements a velocity variable numerical integrator for simulating physical forces on particles. What this means is if you don't want to be intimidated, don't read the documentation for D3 Force. It's not very user-friendly, but hopefully this tutorial will be user-friendly. So what we need to do is we need to make forces that act on these bubbles to put them in the place that we want them to go. So first of all, we want all of our bubbles to kind of cluster in the middle. So there are a few ways to do this, but the one way to do it that all of these methods have in common is we need to create a simulation. So we're going to create a simulation, and we're going to call it simulation, and it is going to be a force simulation. So what a force simulation does is it takes every single one of these circles and it applies forces to them in order to get them to go to a certain place. So we are going to want all of ours to go towards the center. So what we need to do is we create our force simulation up here, and then we are going to use it. So first thing we need to do is we need to feed it all of our data. So we're going to do .nodes data points. One thing you will see in a lot of D3, not tutorials, but examples of force diagrams is they're going to use node and nodes a whole lot. And it just means the circles, but it doesn't always just mean the circles. But usually every node is one of those circles. Okay, so we're going to feed the simulation our nodes, we're going to save, we're going to refresh, and everything is the same as it was before. So what has to happen is these nodes need to be pushed down here by the simulation. And so what you're going to do is a simulation is like a clock. It ticks, it ticks, it ticks, it ticks, it ticks. And every single time, let's say a second goes by, it's going to update the position of all of your nodes, of all of your circles here. But you need to write the code that fires on every tick of the clock, on every tick of the simulation. So we're going to make a function called ticked. And every single time the function is called, it is going to go grab those circles, which we created up here, and we are going to set their cx to be d.x and their cy to be d.y. Now, what this means is when we feed our simulation these nodes, it's going to automatically update all of our data points with the cx or the x and the y that it wants them to be at. So then every single time we go through this tick, we need to update our circles with the x and y that our data points know about. So in order to make this happen on every single tick, we go on tick, ticked. So every single time there's a tick of the clock, fire this code here called ticked. So save it, refresh, and there seems to be something happening over there. All of the circles are indeed being pushed around a little bit by a force, but these numbers seem kind of random. And that's because right now our simulation doesn't know where to put all of these circles. It doesn't know what we want them, where we want them to go, what forces we want to act on them. So we're going to add two forces. So the simulation is a collection of forces about where we want our circles to go and how we want our circles to interact. So in order to add a force, you do .force and then you give it a name and then you define the force right there. So the first thing we're going to do is we need to create a force to push everything towards the middle. Now there are a few ways to do this, but the most flexible is a force called force X and another force called force Y. So force X forces it to go somewhere along the x-axis, and force Y forces it to go somewhere along the y-axis. So right now this is 0, 0, and this is width, height. So let's start with the X force, and we're going to try to push everything to be in the middle. So if we do the math, this is 0, this is width divided by 2. So let's create a new force, we'll call it X, and then we will say we want a new force X, and we want it to send everything to width divided by 2, and we want it to be a little weak. I believe strength is a number between 0 and 1. And a lot of making a force simulation is playing around with those numbers to see the right collection of strengths. So we are going to save this. We are going to refresh. And hey, look at that. It pushes everything towards the middle. Maybe if we make it a little bit stronger, it'll push a little bit more quickly. So let's try 0.05. Hey, look at that. It pushes them all towards the middle. So what's happening is we're creating our circles here after we've read in our data. So we read in our data points. We make a circle for every data point. We say we've created a simulation. Here's all of our data, and every single time there's a tick of the clock, run this function and reposition our circles. This stuff here is kind of magic. You're really going to cut and paste this every single time you have a simulation, so you don't necessarily have to worry about what's happening under the hood. But every single time this tick happens, the simulation looks at all of the forces that we've applied and says, where should all of our nodes be? Where should all of our circles be? And right now we have one force that tries to push everything on the x-axis to the middle. And it's not a very strong force, but it's enough to get everything there. So in the end, it loads it up and it pushes everything towards the middle until they're all chilling out at width divided by 2. So we also want them to go towards the center of the page on the y-axis. So it's the exact same thing, except instead of width divided by 2, it's going to be height divided by 2. So I'm just going to cut and paste this to add a new force. We're going to call this force y. Instead of force x, it is going to be force y, and we're going to send it to height divided by 2. So now there are two forces acting on all of our circles, one pushing it towards the center on the x-axis and one pushing it towards the center on the y-axis. And there you go. They wonderfully settle right in the middle. Now we are using force x and force y. There's another force called force center, but that's not very important to us right now. So what we want to do is, there's a big problem. And all of our circles are in the middle, but they're also all on top of each other. So even though you can see it's wiggling around a little bit exactly where they are, because these numbers aren't all exactly the same, but they're the same enough that we can't see our circles. So what we want to do is not have our circles collide. So let's say step 1, get them to the middle. Step 2, don't have them collide. Now, luckily enough, there's a force, and it is called force collide, and the point of that force is to make things not collide. So let's have a new one, call it collide, D3, force collide. And we're just going to leave that there. We're going to run it. We're going to see what happens. They look like they've made a slightly larger circle, but nothing meaningful. So when we made force x, we gave it the x that we want it to end up at. When we did force y, we gave it the y that we wanted to end up at. When we create a force collide, we give it the radius of the area that we want the collision to avoid. So let's just try 5. So we can see the circles are a little less colliding. Let's say we made that 7. They're a little bit further apart. Now let's make it 10. And now you can see that they're all evenly spaced. So why 10? Well, if we go and look at our code, we see that right here, the circles have a radius of 10. So as long as the radius of the circle matches the radius of the force collide, you're not going to have any overlap between circles. So this looks pretty nice so far. The only issue is we would like these circles to be bigger and smaller, and we're going to base that on the album sales column here. So let us make a scale, var radius scale. It is going to be a square root scale because it is the radius of a circle. The smallest number of albums that are sold was 1 million, I believe. The Fediwap, yes. And the largest number is 300. So we're going to say input somewhere between 1 and 300. And the output, let's make our smallest circle 10 and our largest one maybe a radius of 80. So we'll save that there, and then we will use it when we create our circles. So instead of always making it 10, we're going to have a function, return, scale square root, d sales. So every time we have a circle, it will set the radius based on the sales column using this scale that we just made. So give it a save, give it a refresh. Nope, scale square root is not defined. What did I do wrong here? Oh, no. Oh, okay, here's what I did. Instead of scale square root here, this is radius scale, obviously. Okay, so now we have another problem. The circles are the right size, but they are colliding on top of each other because what we said in our code was always make the force collide be 10. Always make the, let's say, radius of the barrier 10. And because not all of these are 10 now, there is a ton of overlap. So the magic thing about force simulation is instead of just feeding everything numbers, just like how we changed 10 radius to be specific to that one data point and we added a function, we can do the same thing with force collide. So if we want force collide to be the same for every single circle, every single data point, we say, okay, it's always going to be 10. But if we want each of them to have a different collision force, we can add a function in here. So I just set this to be 10. I think it's good practice every time you replace a number with a function, just to make sure you did things right. Put the same number here. So we had force collide 10, and now we have a function that always returns 10. So yes, it looks the same, the error console's fine, everything's good. So what we need to do is we need to make this collision force be the same as our radius. So if we have return radius scale d sales, we can just make the exact same thing happen up here. So as the circle gets bigger, the collision force will also get bigger. Hey, look at that. Wonderful. You can also, if you want to add a little bit of extra spacing between all of these bubbles, you can maybe add +1 to that scale, and you'll push it out, and it'll look beautiful. So one thing that I didn't talk about is where these names come from, the X and the Y and the collide. You can actually name them anything. So I can call this anti-colliding, and I could call this X towards the center and Y towards the center, and it'll still work fine. It's just if you end up wanting to replace or edit these forces later, you're going to need to use their names. So one more quick thing before we go. I'll review this in the next video as well. But we are using the center as width divided by 2, height divided by 2. Now sometimes you want to have the middle of this be 0, 0. So you would like to say force x 0, force y 0. They actually default to being 0, so we could even get rid of those numbers. So if we see right here, they're clustering around 0, 0. If I get rid of this, they are still clustering around 0, 0. One thing I could do is we have this G that everything is hiding inside of, right? If we examine this, we have an SVG, and inside that we have a G with all of our circles. You could say translate width divided by 2, height divided by 2. And what that will do is it will push everything down to have the middle point be 0, 0. Now this isn't always the best thing to do, just depending upon how you're going to be positioning your circles later. I just wanted to give you a shout about that here, just in case you see it in other people's code. So we are going to go back, 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 back to the width divided by 2 and the height divided by 2. And there you have it. We have made a bubble chart where it is going to push everything towards the center. Oh, we'll do one more tiny thing. One more tiny thing to make it a little bit nicer. These circles are the same as any other circles that you might work with. So let's say on click, we can, console.log and examine. This is Madonna, that's Hall & Oates, and then we have the equals over here. So anything, even though these are moving around and these are wiggling, you can still use tooltips, you can still use transitions, you can still use all of the normal things that you would use in a D3 visualization. All the force bit is doing between here and here is it's going to move all of these forces around for you. So instead of setting the Cx and the Cy according to the scale, the Cx and Cy will be set by the simulation in this function. So that wasn't very much extra code. All we did was we added a few different forces, and then we said, hey, apply these forces to all of our circles. And we made a pretty impressive graphic. So, all right,